Hi everybody, my name is Himanshu and in this video I'm going to talk about deep learning and so we'll see how we are going to work with the deep neural network and what are the different type of neural networks and how we are going to do the coding in the Jupyter notebook with the help of Python, TensorFlow and Keras. We have taken a small example also so that people will get at least a small idea how we are going to do the work with the artificial neural network. So, what is artificial intelligence? Artificial intelligence is the ability of a computer program to learn and think. So, whenever we heard this term AI, so first things comes in our mind that is robotics. And we have seen so many movies like Matrix, Transformer, Interstellar. So these are the some best movies which where we have seen the AI next level. So AI is the one of the branch of the computer science where the user will program their machines in such a way that so that machine will think like a human and act like a human and mimic their actions. So if you see the diagram, in this diagram AI is the superset and inside the superset we have a machine learning and we have a deep learning. See, these are two another subset of AI. We'll talk more about this machine learning and deep learning in upcoming slide, but now if we are dealing with the labeled data we are using the machine learning, and if we are dealing with the unlabeled kind of data so then we are going to work with the neural networks inside the deep learning. In the right hand side if you see there are various fields where we are using the artificial intelligence techniques in the face recognition, image classification, medical field, text to speech generations, and auto driving car, and some kind of recommendation systems, and in gaming. So if you see in the Amazon and the Flipkart site, some kind of electronic gadgets, whenever we are purchasing, so the site itself is suggesting some kind of other gadgets. So the people who purchase this item, so they also purchase this item. So this is kind of some kind of real-time kind of recommendation system. And similarly, if we talk about the some speech recognitions, so like in Apple, Siri, and this Amazon uh, Alexa, and in Google that OK Google. So there are some the real-time speech recognition kind of system. Types of learning. So there are three type of learning. One is supervised learning, another one is unsupervised learning, and third one is reinforcement learning. So again, these all are coming under AI only, because if you remember my previous slide, in that one bigger set is the AI, in that one subset is machine learning, and inside the machine learning we have one more set that is called deep learning. So first we'll discuss about the supervised learning. So supervised learning, if I'm taking one example, let's suppose you are doing your PhD and you are doing your PhD under the guidance of your supervisor. So here supervisor is nothing but you are getting some information about the data. So similarly, you are getting the guidance from your supervisor. So here while we are building the data, while we are building the model, so we know about the data behavior. We are getting the label data. In case of supervised learning, we are getting the label data. And now, so getting the label data is nothing but we know the target at the class of the data. Whether if I'm taking a fraud or non-fraud kind of data, so in that case, I know that this kind of data or this kind of stream will come, so it is related to the fraud, or this kind of stream will come, then I will take it as it is a non-fraud kind of data. So here I know the behavior of the data. So what I will need to do, I need to do some pre-processing part, and after that I will feed all this data to my model. Now in model I will put my input data, and corresponding this input data I will put my target attribute, and now I will build my model. Once while I train my model, now next time when I will provide the test data, then on the basis of my training, it will give the output. So label data is nothing but we are getting some information about the data. So now we'll talk about the unsupervised learning. Unsupervised learning is nothing but if, let's suppose I'm doing the PhD and I don't have any guide kind of thing. So similarly, if you relate to the data set, I am having a huge data, but I don't know the which kind of data it is. So data itself is learning from the data. So mostly we are using, let's suppose if we take example of the clustering, so we are using the k-mean clustering algorithm here, and otherwise we are going to play with the deep neural network. We are going to use here neural network part here, and this portion basically we call it as like coming under deep learning. Let's suppose dimensional reduction kind of thing. So we are going to use the autoencoder here, or again it depends upon the use case. If my use case is like I need to do anomaly detection, then I will go for autoencoder neural network. And let's suppose if I'm having some uh, time uh, time series prediction, so in that case I will go for the LSTM neural network here. Or the third one, the third technique, that is reinforcement learning, that in that learning we are not getting any training kind of data in the real time environment. So the model itself learn from the past behavior. So let's suppose you are performing some actions, and this action, maybe you will get the reward, or maybe you will get the some kind of penalty for this action. So now this kind of, from these kind of actions and the history of these actions only, the model will learn itself and it will give the output. And one more thing is that reinforcement learning mostly we are using in the gaming environment while we are building the game related applications. So there only we are mostly using this reinforcement learning. Deep learning in one slide. What is it? Extract the useful pattern from the data. So while we are dealing with the deep learning techniques, in that case, most of the time we are using the neural network. So, and we are receiving the huge amount of data, and the data is unlabeled data. We don't know about anything about the data. So data is learning from itself while we are building the model. So in that case, we need to find out the useful pattern. That useful pattern is nothing but, because while we are building the model, there are some patterns which are abnormal patterns, and there are some patterns which are, that we will find different type of patterns. So in this way, we can do some kind of classification kind of things in the data. So this is how we are classify the data, or at least we'll get some idea of the data, we'll get the behavior of the data. How? We are going to use the neural networks for this. While we are building the things, we are going to use the neural networks, and inside the neural network we are going to use the hyperparameters, because this is the most important part in the neural network. If we are not going to set the hyperparameters values, in that case it is very difficult to find out the what we want to build. So, and we need to do some kind of we need to select some optimization technique also. So we are going to discuss these things in detail in upcoming slide. So in the neural networks also, we need to select which kind of neural network I want to select. So it depends upon the use cases. Like I am dealing with the some kind classification kind of problem. So in that case, definitely I will go for some deep neural network. If I want to use some kind of anomaly related problem, then I will go for autoencoder. And if it is like something related to the NLP related thing, then I will go for uh, um, recurrent neural network. And if I'm going to use something related to the image processing, then I will go for cognitive neural network. And hyperparameter is nothing but inside the neural network, I need to select the number of hidden layer, what are the activation functions, what are the bias value. And in the optimization things, I need to select whether I need to go for the Adam, whether I need to go to the stochastic gradient descent, or I need to go to the stochastic gradient descent. So there are different optimization techniques are available that we're going to see in upcoming slide. And how? So we are going to use basically the Python language here while we are for building the model. And on the top of the Python, we are going to use the TensorFlow and Keras libraries. There are so many different packages are available in the market, but like Theano, Cafe, PyTorch, CNTK. But currently, the people mostly they are using that TensorFlow and Keras because they are very rich libraries, and most of the things are automated here. We need to call the some functions, and the some of the some kind of functionality we don't need to do hard code. And hard part is like while we are building the model, getting the good quality of data. So quality of data is really dependent, it's the most important, because if you are not getting the rich data set, in that case it is very difficult to, either it's a labeled data or unlabeled data. We don't want any kind of missing values or some null values. We want some kind of rich data sets, then only we can do our modeling part. And good approach in the sense, let's suppose we are going to get some problem statement. Definitely we'll do some kind of small R&D on that problem statement, and we'll find out the different forums, what are the process I need to follow, so that I will get the best result or best accuracy for the model. Even though we know how to solve the problem, but definitely we'll do some small R&D, so that we'll get to know more better idea while building the model. And why now? Because data is increasing daily or day by day in every second like anything. So handling this kind of data, we require upgraded hardware also. So like people are generally using the CPU and GPU, so we require some upgraded hardware. And for analyzing this kind of data, we require some upgraded tool. So tools is nothing but TensorFlow, Keras, PyTorch, CNTK. With the Python or R, people are mostly using the Python with the combination of Keras and TensorFlow. So this is how we need to, you know, set the environment. Then only we can do some kind of modeling part. So if we see in this slide, this is the history of the deep learning tools. So you can see the right hand side that Frank Rosenbelt is the first person who did this, who invented this tool that is called Mark 1 perceptron. In 1960s, he built that tool. And after that, it is in 2002, people started working with the Torque, then Theano, then Cafe, then the TensorFlow version 0.1, and then PyTorch. And slowly, in the current time, people are mostly using this TensorFlow 2.0 is the latest version, and the Keras 2.3.1 is the latest version. These are the very rich libraries, and some of the tasks are already inbuilt inside this. We need to call this function, and it is like we need to do some kind of we don't need to do any hard coding kind of thing. We need to call the function, and sometime it is very easy to build the model. So that's why people are nowadays mostly using this TensorFlow and Keras library. The next question is like, why deep learning? If you see the diagram here, you are receiving the input data, but in case of machine learning, manually we need to do some kind of pre-processing part. We need to do select the feature, what are the attribute I need to take while building our model. Some kind of we need to do some kind of categorical encoding part. So these are the steps we need to do manually in the machine learning. And then it depends upon use case, what are the what kind of the model I want to build, whether it's a classification problem or regression problem. According to that, I will use my model. So let's suppose I need to do some kind of classification. I'm using the random forest or decision tree kind of algorithm. And once my feature selection part is worked, once my pre-processing part is completed, I will feed this complete data to uh, my algorithm, the model that I want to build. It's a classification. I will feed my data to random forest, and then I will get some kind of output. And this is how we are building the model in the machine learning. But the same thing when I want to do in the deep learning, I need this features extraction part. I can skip this part here. So the building of the model will take at least less time compared to machine learning. Here we need to do some kind of null value and encoding part. These are the part we need to do. Otherwise we can take all this data element and we can feed at a time in the deep learning. I mean, definitely we are going to use the number of attribute, what are the attribute I need to select. But this is the one advantage here. We can take all the attribute at a time and we can apply in the deep neural network. And then internally, it will do the feature extraction and classification. It will learn from the data, and it will analyze the pattern itself. And then after that, it will give the output. If you see the right hand side diagram, the amount of the data is increasing and the performance wise. So if you are getting the huge amount of data and your data is increasing like anything, so in that case, somehow machine learning algorithms efficiency is less compared to deep learning algorithm. So if you go through the definitions, deep learning algorithm attempt to learn representation by using hierarchy of multiple layer. So here we are going to use this one layer, one hidden layer, second hidden layer, and this is the third one. So this is output layer. So data is passing through different layer, and it will analyze inside the data and different pattern, and then only we'll get the output. So in this slide, I am taking one side, my left hand side, I'm having artificial neuron, and the right hand side, I'm having this biological neuron. So I'm comparing this both type of neuron to each other. So if you see the artificial neurons, we having one is cell body, and we have some input attribute, that is input values x0, x1, x2. And while we are doing these computations inside the node, I am adding some values w0, w1, w2, and I'm adding some bias value wb, and I'm taking all this information I am putting inside the activation function. So why I'm using this, why I'm adding this bias value, and why I'm putting all this value into activation functions, and why I'm adding this weight value to my input attribute, because my data having some kind of linearity. And if I want to perform some kind of computations, so that I will learn from the data, or I understand the behavior of the data. So doing this kind of process in the linear data, it is very difficult. So basically I'm trying to remove the linearity from the data, and then only I will be able to understand or analyze the data in a better way, so that I will get some kind of meaningful output. So if we see in the biological neuron, the input signals are coming. So these are my dendroids. So dendroids, my this you can say as an input, these are accepting this input signals, and after that it is going inside my cell nucleus. So cell nucleus is nothing but here, whatever my cell body here, the same thing here. But inside the mind, my if I'm already having this kind of inputs previously, so definitely my mind will do analyze inside, and it will identify, okay, last time I have seen this kind of informations, and so this is the outcome of this information. Let's suppose I have seen previously human being, cat and dog. Let's suppose I'm taking an example of image kind of thing. So previously I have seen definitely some kind of dog or some kind of cat or any different animals. So I'm having my past information inside my mind. So whenever next time I'm going to see the human being or any cat or dog, so definitely I will try to analyze this data my internally in my mind. And then you can say snaps this synapse is there. So before after once my data is analysis part is completed here, it will send this signal to the with the help of this synapse, and it will send to the my output layer. So output layer here nothing but it is like axon, we call this axon, but in term of artificial neuron we call it as a output function or output node. So this is how we can say, like this is the quick comparison between this biological neuron and this artificial neuron. So if we see the how the neural network is working, so basically I'm having one input layer here, one I'm having a hidden layer, and one I'm having output layer. So if you see here, H is nothing but I have taken this hidden layer. So this is my sigma, my activation functions. W1 I'm adding some kind of weight value. I'm taking only for here for first node. So H1 is equal to sigma plus W1 X I am putting some kind of input variable here, input data, and adding some weight value here, and then bias value, and I'm putting inside the activation function. So why we are doing this thing? Because we want to remove the linearity from the data, so that we can perform some more much complex computations, so that I will get some more meaningful output. So similarly in the output layer also, y is my output layer in that in this node sigma and w2h, whatever the output I am getting from the hidden, this one h is I'm putting here, and I'm taking w2, I'm adding this w2 weight here, and I'm adding some kind of bias value, and then again I'm putting into the sigma function. So we see 4 plus 2, 4, 1, 2, 3, 4, 5, 6. So 4 plus 2 neurons. So 2, 3 into 4, I am putting this value in my hidden layer, another node, 1, 2, 3, 4, 3 into 4, plus I am taking this input data and I'm feeding forward to the my next node, that is my output node. So 4 into 2. So total we have assigned around 20 weight, because these are all are connected to the they are all are connected to the each other. It is like one is connected to the all the four nodes, so it is multi-connected. So similarly in this layer, this is also multi-connected. So total number of the weight we have a 20, and 4 plus 2 I am taking as a input, this is input layer, this is output, and this is hidden. So one is like 4 plus 2. These are total number of the bias, 1, 2, 3, 4. So 4 bias in this layer and 2 bias in this layer. So total number I am having 6 bias. So these are nothing but we call these hyperparameters, and we need to set some kind of these values also, number of hidden layer. So that we are going to see in upcoming slide. We're going to see the deep neural network, but this is how we are going to perform the small computation things inside the node, so that we'll get some kind of meaningful data for the my next layer. So here we can see the difference between the simple neural network and the deep neural network. So if we see my left hand side, this is my simple neural network, in which I am having one is input, one is hidden, and one is output layer. So I am having total one hidden layer here. And in the same thing, if I see the right hand side image, in this I am having 1, 2, 3, 4 number of hidden layer. So if you see the the computation power here, I am having more computation power compared to this. So whatever the value I am trying to predict for my input data, it will be I will get more good result compared to this neural network, because I am having different combinations of the data here. And one more thing is here, sometime what will happen according to my use cases, sometime I can switch off this node and I can on switch node, means depends upon my the way I am going to compute the data. I can sometimes switch off the some node and I can on the some node, so that uh, this is also one of the way to how to predict the information. Sometimes you will get some more good result in that case. But inside the node, as I told in my previous slide, we having bias value, we having activation functions. I'm having some kind of node weight value. Why we are adding? Because we want to remove the linearity, as well as we want to normalize our data. We want to remove the outlier kind of thing from my. So while building the model on this kind of data, it will be easy to understand for my neural network. And one more thing is here. Let's suppose I'm having already some output values here, because deep neural network we can use in both kind of either it's a labeled data or unlabeled data. We can use in both, but most of the time people are using only for the unlabeled data. Let's suppose I'm having already some output values here. Now what I will do, the process is called the back propagation. So whatever my here I'm going to get the some predicted values. What I will do, I will compare this my actual output, and it will calculate some kind of error. So this is nothing but some kind of error rate, and on the base of this error, we our goal is to minimize this error. And so what will happen, it will start feeding the data in the back direction. It will start doing the direction like from here to here and from here to here. So it will start working in the back propagations, and it will adjust the error rate, as well as it will adjust the number of the that weight value. And again it will send the data to my the first of all it will go to the back propagation, and then will start again this feed forward. It behave like in feed forward direction. Then again it will calculate the error. So this process will be continue until and unless my error rate is not become very less. So so this complete process is basically called the back propagation method in the neural network. So again I have taken I just given the small descriptions of the forward pass and the backward pass here. If you see, the I'm applying this input data to already build my neural networks, and it will giving some kind of output values here. So we call it as a predicted values, and I'm having already some kind of output values, actual output values. And I will try to compare these predicted values and output values to each other, and after that we'll see what is the errors we are getting. So according to this error rate, again we start feeding the data into the backward directions, and this process will do until unless our error rate is not going to less. So this process is called the backward, this is called backward pass, and this is called the forward pass. So if you compare this human or the machines, there are basically human will take very less number of the examples while we are in learning phase. So let's suppose first time I have seen some kind of pet animals. So definitely I will analyze the things. I will understand the object size, shape, color, and a different number of the features of that particular pet. And once I will analyze the things, when the next time I'm going to see these things, definitely in my mind I will analyze the all these parameters, and immediately I will say, okay, this is the cat, this is a cow, or this is a uh, dog. So this is, but in term of machines, to analyzing the machines require a lot of data. So here if you give the millions of the data, then only machine will be able to understand properly. And in that also my data set is not richful, then again it's a big problem for the machines. So while we are feeding the data, make sure our data set is very highly richful, so that it will take less effort to get the output. So why is DL useful? So if you see, if you compare this machine learning, we need to do some kind of feature extractions kind of part. But here manually designed features are often over specified, incomplete, and take a long time to design and validate. So it will take some time in terms of machine learning. But learned features are easy to adapt and fast to learn. So what we'll do, we can take all the feature at a time, and we can start feeding into the our neural network. Deep learning provides a very flexible and universal learnable framework for representations, word, visualization, linguistic information. So we are using deep learning in image processing, speech recognition, pattern recognition, text minings, and recommendation systems in real time or near real time. In every field, we are using this deep learning in current time, and can learn both unsupervised and supervised. So we can, as I told in my previous slide, it is not necessary we can use the deep learning only unsupervised learning. We can use in supervised learning also. And effective end-to-end joint system learning and utilize large amount of training data. The only thing is that we require large amount of data. Why? Because neural networks learn from the data only. So we require large amount of data while we are building the model. In this slide, we are going to talk about the hyperparameter. So hyperparameters are the variable which determine the network structures. So basically, first one is the hidden layer and the variables which determine how the network is trained. So there are different type of hyperparameters. We having one is the dropout, one is network weight initializations and activation function, learning rate, bias, and number of the epochs and the batch size. So bias is nothing but the additional parameter in the neural network which is used to adjust the output along with the weight, sum of the input to the neuron. It helps the model in a way that it can fit best for the given data. And the batch size is the number of sample processed before the model is updated. The number of epochs is the number of complete passes through the training data set. So here we have taken a small example so that we'll get a good idea about what are these terms, batch size, epochs and all. So let's assume we have a data set of 200 sample. So I'm having 200 number of the records, and so I have taken my batch size is equal to 5, and number of epochs I have taken the 1000. So 1000 time my data will be going to pass in the neural network. So this means the data set will be divided into the 40 rows. So each batch having the 200 divided by 5, so each batch having 40 number of the records. So total I'm having total 200 samples, and number of the batches I'm having 5, and each batch having 40 number of records. So now what will happen, the model weight will be updated after each batch 5 samples. So with 1000 epochs the model will be exposed or passed through the whole dataset 1000 times. So now what will happen in the one epoch, this all 5 batches means all my 40 and this 40 and this 40 and this 40, all my 5 batches in which I am having 40 records, it will be pass in the data in the neural networks, and it will adjust the in every pass it will adjust the weight, and then again it will process in the neural network. So like the way we are going to reduce our error rate. So one is the dropout is nothing but, let's suppose in my hidden layer, in my neural network number of hidden layers are, I'm using the 4 number of hidden layer. So in the first layer I'm using this 10 number of input parameters. So in the next layer, how many number of attribute I'm going to forward. So what I will do, I will drop out the two layers, two nodes. So in me it means, so 8 number of the nodes value I'm going to transfer in my uh, next layer. So in my 8 number of nodes in my next layer, now what I will do, I will set my dropout rate will be 0.2. So 0.2 is nothing but 20% data I'm going to drop out, and in this 80% data, so this in this all these 8 nodes, what I will do, again I will drop these two columns, two nodes values, and I will forward this 6 number of nodes value I will transfer in my next node. So in this way we are going to build our model. And the network weight, we are initializing some kind of weight initially, activation function sigmoid 10h, and learning rate we are calculating the error rate, and then according to that we are going to set our learning rate. Number of epochs we have described in here, and the batch size also we have described. So bias is nothing but we are adding some external value to the inside the node, so that some kind of will take care of linearity and the scaling of my data set. In these functions, why we are using this activation function? So we must use activation functions such as ReLU, sigmoid and 10h in order to add the non-linear property to the neural network. In this way the network can model more complex relationships and patterns in the data set, because in the linear data it is very difficult to get the more complex relationship and patterns. But in case of non-linear data, we can easily predict some more complex relationships and more patterns, so that model will learn internally some more different combinations of the data, and it will get more complex patterns, so that it will be helpful while we are predicted the value. Activation function decides whether a neuron should be activated or not by calculating weight sum and further adding the bias weight. The purpose of this activation function is to introduce the non-linearity into the output of the neuron. So in, if I'm telling in this, if I say in single line, why we are using this all these hyperparameters, we want to remove the linearity, we want to scale my complete data set, and we want to remove the all kind of outlier. So while building the model, if this kind of things are completed inside the every node, so building will be building the model, it will be very easy. So you can see the range of the sigmoid functions here. I'm having 0 to 1, and the 10h range will be -1 to +1. So most of the time what will happen here, In the first layer, maybe I will use the ReLU function first, or maybe I will use the 10H function first. It depends upon the use cases or depends upon my requirement. I can use the first in the first layer, I can use the ReLU function, and the second layer I can use the 10H functions, and the final layer I can use the sigmoid functions. Or sometime what will happen, I can use single activation functions across the neural network. So this is the range for the sigmoid, that is 0 to 1, and that is -1 to +1, and for the ReLU function 0 to max. So you can say there are some other advantage of the ReLU function is that training much faster and the less expensive operations compared to sigmoid and 10H activation function. So why do we need the better optimizations? So our goal is to find out those attribute or those parameters values in which my the cost, my I can minimize my cost. So here basically what will happen, slowly in each and every epochs, what will happen will we are trying to minimize our error. So our best this is the point where we are to get the minimum cost. So in each and every individual epochs, our job is to get reduce the error rate, and we'll get the best output where my cost will be very less. So this method is basically nothing but this will it's coming under optimization. So to train a neural network, we must define a loss function in order to measure the difference between our model prediction and the label that we have that we want to predict. So it will take the difference of actual data, that actual output data, and the predicted data, and it will calculate the mean error and the point where we are going to get the less this error. We will stop that particular point, and that point is basically nothing but we call this as a this is the point where I'm getting universal minima. That point basically we call it universal minima. So what we are looking for is certain set of weights with which the neural network can make the accurate predictions, which automatically leads a lower value of the loss function. So in case of optimizations, we are using the different optimization techniques like gradient descent, Adam, and stochastic gradient descent. So these are some different optimization techniques are here. So we can see that gradient descent is the optimization algorithm used to find out the value parameter of a functions that minimize the cost of a function. So here we can see there are two optimization techniques which are very famous nowadays. One is the Adam, and the second one is stochastic gradient descent. So Adam is basically helpful when your data set is very sparse or very noisy data set, and your number of the parameters in the data sets are very large, or you can say the number of parameters are more. So in that case your Adam will be best optimizers, or your data set is also very large. In that case also Adam will be very good. But the stochastic gradient descent is like it is good for other small data set, and if your data set having noisy in that case the stochastic gradient descent is not that much helpful. People generally using this Adam function. So here you can see so in this Adam function we are getting most of the time this good learning rate, this kind of thing. And stochastic gradient descent, from this we are most of the time we are getting this low learning rate. And sometimes there are some other uh, methods, other optimization techniques. For that you can see that sometimes we are getting very high learning rate, and sometimes we can see the high learning rate. So but the decent learning rate is this one, good learning rate, this one that we are receiving from most of the time with the Adam function. So basically in this slide I'm going to give the small demo how the neural network is working. So so there is a one site basically we call it playground.tensorflow.org. So if you click in this one, you'll get some this site, it will open. So just for demo purpose it is. So what will happen here, according to my feasibility, I can increase the number of hidden layer like this. So this is only for the demo purpose, and I can increase the number of nodes here also, and here also I can increase the number of node here like this. Now these are my epochs, how many time my data will pass in the neural network. And if I want to increase here, again I want to increase the number of hidden layer like this, and then four number of 1 2 3 4 5, and here also. And then I will putting this classification problem. So I'm selecting here from either we can use the classification or the regression problem. If I'm using the classification, I will get like this. If I'm using this one, so it will get some kind of linear regression. And but here I'm going to take the classification thing. And then what I will do, I will use the which are the activation function I want to use. People are generally using this ReLU, 10H, and sigmoid activation functions. So I'm going to use the 10H activation functions here, and learning rate will be 0.03. And so let's check out how it is working. So we can see number of 10 epochs and my classifications problem. So the orange one and the blue one. Total number of the 87 epoch I have taken, so means 87 number of times my data is passing from again from here to there, and the backward directions and forward direction, and then I'm getting this kind of the output. So this is the quick small demo of the how the neural networks are working. So if you want to go for the more in the more details, so people can visit this site and they can build their own neural network and they can read this complete information. And at the end I have taken one demo here. So what I'm going to do, initially I told that I have taken one example of next best offer. So we'll see the example. So this is my data set I'm having. So first of all, I have taken all the packages which are really required while building the model. So I have included this deep learning package, TensorFlows, and Keras also here. So you can see Keras modules here, and the TensorFlow is also there. So because while we are building the models in the neural networks, these are the some latest packages. People generally are using this TensorFlow and Keras. And then in this file, I have saved my data, this nbo.csv next best offer. So you can see how the data is look like. So our goal is to for this particular MSISDN, and these are my attribute values, and the reason ID, transactions count, which kind of service type he has taken, customer segmentations, and average revenue per user, that is current month, and then last date product, and last second date product, and last three. So for this particular MSISDN, I am having this three type of this offer. So my main goal is to find out the propensity of which of the offer that user is going to take next time. So I need to calculate the propensity for this particular MSISDN. So what I will do, I will take my whatever the columns I want to take, because here I am putting in everything in the neural networks. So I have dropping some column which are my target attribute that I'm not going to take, and I have taken all the input element, all my input. This one, first of all, what I will do, I need to do encoding in this one, and whichever my categorical attribute, I need to do encoding here. So I did the encoding here, and then once I did the encoding, what I will do, I will perform the so encoding part is done. Now I have performed the min-max scaling on my data set, so that my complete data set will be in the range of 0 to 1. Scaling is really required because so that you can remove the any kind of outlier is there in your data, so it will remove, because it will be really helpful while we are building the model, and it will impact the accuracy of the model. So anyhow we are if we are going to do this, definitely we are going to get the more accuracy in my model. And the similar thing I did in my what I did, I converted into the encoded the all these informations. I encoded these values, and then I have performed the normalizations. I have performed the min-max scaling here also. So after that it's look like, so this is my encoding part, and then I perform the min-max scaling on this also. So again my value between 0 to 1 here. So now what I did, I have taken 80% I have taken as a training data, and 20% I have taken my testing data. And so this is how in the first layer number of layer I have taken 1 2 3 number of hidden layer I have taken here, and this is my input layer, this is my output layer. So I told in my previous slides, like I can use the different number of the activation functions, but nowadays people are using this ReLU and sigmoid 10H activation functions. So here I have taken the in the first three layer, and in the first four layer I have taken the ReLU functions, and in the last layer I have taken this sigmoid function. And you can see here the optimizer that I have taken, that is Adam optimizer. optimizer. So why I have taken Adam optimizer compared to stochastic gradient descent? This is the optimizer is really helpful while we having number of parameters are more, and if my data having some kind of sparse or you can say noisy data, so in that case Adam is a good optimizer. So I have taken Adam here. And then what I will do, I have taken this number of epochs 120, 150, and the batch size I have taken 38. So number of 150 time my complete data will be moving in the forward directions and the backward direction until unless my accuracy is not going to increase and loss value is going to decrease. If you see this thing, it is 0.1249, and my loss I am making it 0.0515, and accuracy I am getting 77%. So, and the next thing is like batch size. So batch size I have taken 38, in the sense it will divide the complete data into the 38 of batches. It is taking the randomly data, and each and the each batch, it will in like total number of the batches are 38, so it will take randomly selected the the rows in the data set, and it will start passing the data in the model, and then this prediction happened. So you can see the accuracy result. You can see this is for my training data, and for my validation purpose also I'm reaching around 77%. So this is the graphical representation of this. So once our model is done, then after that what I will do, I will perform this test data to my model, because this is 20% of data. For that I want to build my model. For that I want to predict the propensity for my MSISTN. So now if we see, where is my last final, here. So this is my predicted propensity for this. So this is the MSISDN, and for this offer, this is the propensity. For this offer, this is the propensity. For this offer, this is the propensity. So next time we can simply say that on the base of this score value, we can say that okay, this is the product maybe going to take. So the for this particular MSISDN, next best offer is this one. So this is how we are calculating the score with the help of neural network. So here I have taken the deep neural network. Similarly, for this MSISDN, the next best offer is this one, and for this MSISDN, next best offer is for, I'm getting the score, high score for this product. So similarly, people can assign, okay, this is for this MSISDN. If I'm going to give the this offer, so maybe there is a more chances compared to these two product or these two offers. So this is how we are doing the modeling. So that was the quick introductions of the deep neural networks. So we have seen is we have taken one small example also, and in that example we are trying to predict the next best offer for particular MSISTN. So MSISTN is nothing but a unique ID, and corresponding this MSISTN we have a different offers, and so in the future that particular user is going to take the which offer. So on the base of this propensity scores, we can simply say that the offer which is having more scores, we can say that this is maybe the next best offer for that particular user. So if you have any query related to this example, and if you have anything related to the deep learning, if you have any query, please let me know. You can comment below. You can ask in the comment sections. And if you like my video, please hit the like button and subscribe my channel. Thank you.